and welcome back to Med School Radio. We are taking another look at first aid. We're looking at cardiovascular section of first aid, page 238 of the 2019 version. We're looking at some cardiac output equations. Let's start with stroke volume. We mentioned it in a previous podcast, but let's go over it again. Remember that stroke volume is SV equals EDV minus ESV, or stroke volume is equal to end diastolic volume minus end systolic volume. So as an example found in Wikipedia, you have to think of, for example, in a healthy 70 kilogram man, end systolic volume is approximately 50 milliliters. So when you are adding end diastolic volume, which is 120 milliliters, the difference is 70 milliliters for the stroke volume. So let's look at this again. Stroke volume is EDV minus ESV. So in this case, the end diastolic volume is 120 milliliters minus the end systolic volume, which is 50 milliliters. So that's how you get 70 milliliters. So the stroke volume here is 70 milliliters. So in the next section they show ejection fraction. And this comes up a lot, of course. So the equation here, ejection fraction equals stroke volume over end diastolic volume, which equals end diastolic volume minus end systolic volume over end diastolic volume. Don't be confused. Think of it simply. Ejection fraction is an index of ventricular contractility. So remember that there is a decrease in systolic heart failure, but it is usually normal in diastolic heart failure. That's what it says in first aid. Next, cardiac output. The formula here is cardiac output is equal to stroke volume times heart rate. And we are supposed to remember the Fick principle, which is cardiac output is equal to the rate of oxygen consumption over arterial oxygen content minus venous oxygen content. So the notes here say, in the early stages of exercise, cardiac output is maintained by an increase in heart rate and an increase in stroke volume. In the later stages, cardiac output is maintained by an increase in heart rate only, and the stroke volume plateaus. So the diastole is shortened with an increase in heart rate. So as the heart rate gets faster and faster, the diastole is shortened. For example, with ventricular tachycardia, which leads to a decrease in diastolic filling time, which leads to a decrease in systolic volume, which leads to a decrease in cardiac output. Okay, next one is pulse pressure. Pulse pressure is equal to the systolic blood pressure minus the diastolic blood pressure. The notes here say pulse pressure is directly proportional to stroke volume and inversely proportional to arterial compliance. An increase in pulse pressure is seen, for example, in hyperthyroidism, aortic regurgitation, aortic stiffening. Think of isolated systolic hypertension in the elderly. Obstructive sleep apnea. So in parentheses it says an increase in sympathetic tone. Then anemia and exercise, which is transient. And a decrease in pulse pressure is seen in aortic stenosis, cardiogenic shock, cardiac tamponade, and advanced heart failure. Okay, the next one here listed in this book is the mean arterial pressure, MAP, equals CO times TPR, where the mean arterial pressure is equal to cardiac output times total peripheral resistance. So the notes say the MAP at resting heart rate is equal to 2/3 the diastolic blood pressure plus 1/3 of the systolic blood pressure, which equals diastolic blood pressure plus 1/3 of the pulse pressure. If you can remember that, you're amazing. Next, the Starling curve. So they have a nice illustration here showing ventricular end diastolic volume or preload on the x-axis, and on the y-axis stroke volume or cardiac output. And the notes here say force of contraction is proportional to end diastolic length of cardiac muscle fiber, which is preload. And there is an increase in contractility with catecholamines, positive inotropes, for example, digoxin, and a decrease in contractility with the loss of myocardium, for example, with an MI. And with beta blockers, which is an acute decrease in contractility, and non-dihydropyridine calcium channel blockers, and dilated cardiomyopathy. Anyway, that's what we have today for this page 283 in the 2019 version of First Aid.